Alright, so here we are in section 3.5. We're talking about translating sentences into equations, and we're also talking about solving integer problems. So we're going to do a couple of those together, a couple of those in this video. So let's start by translating sentences into equations. I think we're going to do this second and this first. So when I translate a sentence into an equation, my recommendation is to separate and conquer. I think the phrase is usually divide and conquer, but divide is too mathy, so I decided that I'm going to describe it as to separate and conquer. So we're going to try and separate any sentences that we see with something special. And the first step, I guess, is to separate. Separate by using the equal sign. So we're going to try and find that equal sign all the time. And that equal sign sometimes can be decided or described as equals, is equal to some of these, was, were, anything that's is or a present or future tense of to be translates into that equal sign. And the equal sign tells us that we can separate that. Should say separated into two sides. So we'll have one side that's a phrase, and we'll translate that into a math statement. And the other side is going to be another phrase, and that will be an expression, and that expression sometimes is a number, sometimes is a phrase that needs to be translated as well. But we're going to try and find that equal sign so that we can separate one phrase from another, and then the equal sign will be right between them, and we'll be able to translate that sentence into math. And then the third step, if it's asked of us, we'll solve that equation. Alright, so let's get started here with just something pretty straightforward. Again, we're going to find that is, and that's going to be the dividing line, that separator between one phrase and another. That is becomes an equal sign. So there's my equal sign. And on the left side, we're going to have a phrase. On the right side, we're going to have another phrase. So 13. 13 is a mathematical statement. Well, that's pretty much easy to be 13. We translated that already. So now let's try and translate this blue statement. So here's our steps. Find that is, separate. The right side is 13. The left side is also, it's a blue statement. Let's try and translate that statement into math. 5 less than a number. Well, a number could be anything. It could be our variable, could be x, could be y, could be z, could be n, could be whatever variable we want to call it, but we'll usually call it x. But this statement in London Blue says 5 less than a number. So there's my number. I don't know what it is. And that's this blue statement says it's 5 less than that number. So it's x minus 5. Whatever that number is, it's x minus 5, and that's 5 less than a number. And there's our statement. We've translated. The equation said, or sorry, the instruction said translate. Here's our English statement. And there's our translation. And we're done. Didn't say solve, so we're pretty much done. But that's how we're going to do that. That's how we're going to work with these examples. So before we get to too many different examples, we're going to talk about integers, because integers are going to be something that we're going to be using quite a bit. Hang on a second. That's better. All right, so we're going to talk about integers. Integers are basically just the counting numbers, 1, 2, 3, and the negative counting numbers, -1, -2, -3, and 0. So it includes all those, -3, -4, -5, all those numbers back there, and all the numbers up here, 1, 2, 3, 4, 5, 6, etc., all the way up to infinity and beyond, just like Buzz Lightyear. All right, so if we're talking about integers, there's the integers. We're going to talk about those and kind of solve for some of those. If we talk about even integers, well, the even numbers are just those numbers, those integers that are evenly divisible by 2. I had one international student who didn't know what even was. He was lost for about half of my class one day because he didn't know what even was. So here's what even is. But even integers are the numbers that are integers that are even. So we got 0, and we got 2, and we got 4, and 6, and 8, and 10, etc. And we got all those negative numbers as well, -2, -4, -6. So those are the even integers. Integers, even integers. All right. I suppose we could talk about odd integers also, just so we can have an idea. Odd integers are the numbers that kind of fall between these guys. -5, -3, -1, 1, 3, 5, dot, dot, dot in both directions. So there's odd integers and even integers as well. So now if we're talking about consecutive integers, that's the next thing that we can talk about, because we'll be talking about these and kind of using these ideas in different applications later on. Consecutive integers are integers that come right after one another. 0, 1, 2, 7, 8, 9. And if we're talking about consecutive integers that we don't know, we'd set them up something like this. It'd be n, some number n. We'll just throw it out as n. It could be x, could be y, whatever. We'll use n. And if this is n, then the next consecutive integer would be n plus 1. Just like 7 to 8 is 7 plus 1. And then if we're deciding that n is 7, then the next consecutive integer would be from 8 would 9, but described by 7, it would be n plus 2. It's 2 away from that one. So here's 3 consecutive integers, n plus 1, n plus 2. And they could represent any of these numbers, 0, 1, 2, 7, 8, 9. But we're gonna use these to solve consecutive integer problems. So if we know consecutive integers, we can say that consecutive even integers would be n. Starting with n, if we've got an example of 2 and 4 and 6, then our first even integer is 2. That would be n. The next even integer would be 4, but that would be 2 away from that 2, so it'd be n plus 2. And then 6 would be the next one in our consecutive even integers, but that 6 would be 4 away from 2, because it'd be 2 to get to here and 2 to get to here, so it'd be n, and n plus 2, and n plus 4, and we'd call these consecutive even integers. And then consecutive odd integers would be these as well, 5 and 7 and 9. Just an example, 5 and 7 and 9. And it's the same type of idea as the even integers. If you start with the unknown n as the first consecutive odd integer, then 2 steps away is the next consecutive odd integer, and 2 more steps away would be the next consecutive odd integer. But in terms of that first integer, it'd be n and n plus 2 and n plus 4, and we'd use these ideas to solve problems with consecutive even and odd integers. And there's kind of our description. So we're going to get to this in just a second.